This meeting is being recorded.
In Chapter 7, we're going to take a look at a specific type of compound referred to as an alkyl halide. And we're also going to look at two specific types of reactions that these compounds go through. The first is called a nucleophilic substitution, and the second is an elimination reaction. So what exactly is an alkyl halide? So what we see here are three different classes of compounds, and this X is indicating either a chloro, bromo, or iodo substituent in place of these compounds here. So what we see in this first picture is what would be termed an alkyl halide. So the first structure, and the carbon, we're told here, is sp3 hybridized as compared to an aryl halide in the middle or a vinyl halide shown over here. These are both sp2 hybridized. So that's the difference between the types of reactions that we're going to see. Alkyl halides are sp3 hybridized, so that's why those types of compounds will react in this certain fashion. So let's take a look here at these two reactions specifically. So first we have substitution shown here. And this is just a general structure of our alkyl halide. So we see in the black our carbon atoms, and the red X indicates our halogen. Then we have, with substitution, we have what's termed here a nucleophile. And this is actually going to be a nucleophilic substitution, specifically, where the nucleophile displaces that halogen and becomes part of our compound now. With an elimination reaction, as we see in this second row here, we have what we're going to learn is a tertiary substrate here, where our carbon in the middle that's bonded to our halogen in our alkyl halide is also bonded to three other carbons. So at that site there, we're going to that halogen will be lost in this reaction mechanism. We'll see it's called a leaving group, and this base here will initiate this elimination reaction. So in a substitution reaction, we should note that we have a nucleophile, and with an elimination reaction, our reagent is going to be a base. So what do nucleophiles and bases have in common? Well, a lot of times they will have lone pairs, right? So nucleophiles, or rather they can have both have negative charges and lone pairs. Nucleophiles sometimes are neutral as well, but they react in a similar fashion because of these lone pairs. So let's take a look at when a reagent can act as both a nucleophile or a base. We're going to have a competing reaction pathway that results. So here we have our secondary substrate. So which compound is our substrate? We see here we have this 1, 2, 3 carbon chain. On carbon 2 is our chloro, so we have a 2-chloropropane substrate, and we have sodium hydroxide here as our reagent, and sodium hydroxide can act as either a nucleophile or a base. So what we see here is when it acts as a base, we're going to have an elimination product, which would also be our major product with this specific substrate, we will see. And then as it acts as a nucleophile, we would end up over here with a substitution that occurs. So this is our minor product noted for a secondary substrate. So, why do alkyl halides undergo substitution and elimination reactions? Well, the halogen that is attached to what we refer to as the alpha carbon, so the carbon with the X substituent on it, this halogen is an electron withdrawing group. So, this creates a partial positive charge on that carbon. So, that is then going to be an electrophilic site which would be susceptible to nucleophilic attack. The halogen also acts as what we call a leaving group for our substrate to have both this substitution and elimination reaction. So that X group must be a good leaving group for this to occur. So let's take a look at some leaving groups here on this slide. And the best leaving groups shown up here, we should note, are going to be conjugate bases of strong acids. So we have some of the stronger acids listed up here, and their conjugate base, in this case, the iodide ion or bromide or chloride seen here, will all be really good leaving groups. So whenever we have those alkyl halides, we can see these types of reactions occur. So we'll continue with nomenclature in the next video.